Welcome to this web lecture about the transition from requirements to design. Good understanding of the problem space of the requirements helps us to make the right decisions for designing a new interface. For instance, for selecting the interaction style, the kind of interface, behavior of the interface, and also which functionality to really provide and which functionality is extras that might be useful but might also be a problem for users who accidentally invoke it. Before we can actually decide upon the development of the design, we first have to come up with a conceptual model. A conceptual model essentially says, how will the system appear to the users? How will users understand the workings of the system? In principle, it is a high-level description of the system that we design. That's one of the keywords in terms of integrated ideas and concepts. This leads to consistency, right? About what the system should do, also what it should look like, right? And how users will understand it, whether users will understand the system in the way we intended it. Right? Often we see users abusing a system for something it is not designed for. And a good example of that is users using a spreadsheet just to create data in a table format. What will the users be doing when they carry out their tasks with the interface? How will the system support what they are doing? And we should emphasize that the system should offer choices where the users have to make choices, and where carrying out the task is self-explanatory, the system can automate them. Which interface style are we going to use? Which interface metaphors will we use? What kinds of interaction modes? Where are we going to use menus, show forms, right? Or where do we use direct manipulation? We have to find out where to draw our alternatives from. Here, working with the users is sometimes a problem in participatory design because humans tend to stick to what they know works. So if they already have a software product and an interface with which they can perform a task, it's hard for users to think of a different way to achieve the same goals. However, it's important that we do consider alternatives. We need to break out of the box of the mindset that we have with the existing applications to come up with brilliant, groundbreaking new ideas. Trainers and designers are trained to consider such alternatives. Software engineers typically are not. So we really need to become designers, right, who consider different options for interaction without immediately thinking of what will it involve technically. Do we have existing, say, software modules that can do what we want? This requires sometimes flair and creativity. Maybe we don't have that. Maybe we don't have a lot of imagination. What we need to do is research many different interactive systems, right? And synthesize which ideas could we borrow from other systems, which ideas do we not borrow. We seek inspiration in other things that exist, maybe in very different application areas. Right? If you don't come up with a good idea by yourself, right, steal. That's essentially what happens all the time. Right? Look at solutions for different problems and see if you can apply them to your problem. It's better to steal a good idea than to come up with a bad idea yourself. Okay, so now we have stolen a number of ideas, and we need to choose which one we are going to develop further. For that, we do evaluation with users. Real evaluation will require prototypes. That's further on in the process. We will also first study technical feasibility. Some of our brilliant ideas we cannot realize. Some of our ideas nobody can realize. Right? We have a great idea for space travel. Right? It's the warp drive. It's presented in many science fiction movies and series. It's a great idea. Unfortunately, it's not technically feasible. We also have quality thresholds. And here, the message is essentially a sad message. Right? On the one hand, we want to create a perfect product. On the other hand, there are realistic limitations to what we can do. We should set forth, first of all, usability goals. They will tell us criteria that the system must satisfy, and we set them early on. For that, we look back at usability criteria we saw in different web lectures, like safety. How safe do we want an application to be? How often do we want users to say, yes, I really want this, so that they don't make an error by mistake? Right? Which functions must the application have, which are superfluous? How effective should the interface be? How much of the task needs to be automated and possible with the interface, and which things are beyond the scope of what we can implement? And there's efficiency issues. Right? Where, for instance, does the system have to react within 1/10 of a second, and where is waiting for 2 seconds acceptable? We've seen these criteria before. We have to set our goals in a realistic way. And we start designing without computers. We start to come up with the requirements with interviews and questionnaires and surveys. Right? So that we know what is needed, what are the users expecting, and what knowledge do they bring in to the design from their domain knowledge, but also which knowledge can we expect our new users to have. And we will start with brainstorming. Brainstorming is a great activity in which no idea is too crazy to mention. So we gather all possible ideas. And once we've done that, and this typically involves writing things on paper, on a whiteboard, we gather all these ideas, we take pictures of them, and we also need explanations of the methods to tell our end users how the design process works. They may also have really nice, crazy ideas, and they will normally be afraid to mention them. So we need to explain, no, we need to get all the possible ideas. And then we perhaps will discard some of these ideas, and others we develop further. We create mock-ups. A mock-up can be a drawing. It can be something somewhat interactive by playing with yellow sticky notes that we paste onto a whiteboard. A well-known mock-up also was when the designers of the Palm Pilot, the first personal digital assistant, say the iPhone without phone functionality, right? When they were designing that, they first had to get an idea like, what is it like to walk around with such a device and to write your appointments into that device and write notes? And so the initial designer cut out the Palm Pilot out of a piece of wood. So you would have this lump of wood and a stylus and carry that around. And he would pretend to be taking notes on the Palm Pilot and writing down his appointments. just to get an impression of what is that going to be like. This is a very typical example of what we call a mock-up. Mock-ups very often are physical things. In software, we sometimes use storyboarding. We use some bit of software that lets us draw something and perhaps paste some screenshots together to give an impression, right, how the interface will work. Once we know how the design will work, we can already start writing tutorials and manuals. So we're going to write documentation of a non-existent system. And we give the documentation to our prospective users, so they can study and see already from the tutorials, right, what is the use going to be like? Am I missing things? And are there things that should be changed? And this is actually behavior that we see in practice. Very often when a new device is going to be introduced, like a company is coming out with a new camera, they will either officially publish or leak manuals so that people can already look into the manual of the new camera, which doesn't exist yet, and then they will actually monitor discussion forums to see what do people actually say about the non-existent new camera based just on the written information about it. It's very important for you to start evaluating your initial ideas for the project based on what you write, based on sketches, before you start programming. We often get comments that the final project involves a lot of programming work. And the reason for that is that a lot of the programming has to be redone because the design was bad. And there is too much programming versus other activities because our students, you, tend to not spend enough time on this early phase of translating requirements into a design before you start writing code. So keep this in mind. Thank you for participating.